let's do another titration example. Let's say it took 80 milliliters of HCl to neutralize 200 milliliters of 0.050 molar magnesium hydroxide. What is the molarity of the HCl solution? So we are titrating to the equivalence point, and the equivalence point is where the moles of H plus that we're adding are equal to the moles of OH minus that are present in the original solution. So we first want to write down an equation for what is happening in this reaction. So we have magnesium hydroxide in aqueous solution reacting with HCl. So we need to write down the reaction and then balance it for what happens when the acid encounters the base. Of course, we're going to make water, so liquid water is going to be one of the products. And then we're going to write down an expression for the counter ions. Now, MgCl are going to come together in a ratio of 2 Cl's for every 1 Mg. And that's necessary because Mg is a 2 plus ion and each Cl is a minus 1 ion. So we need 2 chlorides to balance out the 2 plus on the magnesium. That is really crucial to write down correctly because it determines how we balance the reaction. I must balance this reaction if I'm going to do the stoichiometric calculations. So I can see right away that I need to put a 2 here to balance out the chlorines. And that will necessitate putting a 2 here to balance out the hydrogens. And now it looks like I am balanced. Okay, so it was really crucial to get this ratio correct to determine what the final balanced reaction should be. So now I need to figure out the number of moles of OH minus that I have present by multiplying the volume times the concentration. So let's start by doing that. I have 200 milliliters of 0.050 molar, that's moles of magnesium hydroxide, per liter. Let's make sure to convert the unit. So I have 1,000 milliliters in a liter. And this will enable me to get rid of the volume unit so I get the number of moles of magnesium hydroxide that I have. Now, I need to use the balanced equation to see that I have 2 moles of HCl for every 1 mole of magnesium hydroxide. So that means that I can put that stoichiometric ratio into my calculation here, 2 moles of HCl for every 1 mole of magnesium hydroxide. This will enable me to cancel out the moles of magnesium hydroxide, and now I have determined the number of moles of H plus that I've added. So that is key. So let's put that, you can put that into your calculator, 200 times 0.05 times 2 divided by 1,000 gives 0.020 moles of HCl. And now I know that that's how many moles are in the 80 milliliters. So to get the concentration of the HCl, okay, I'm going to put brackets around HCl. When I put square brackets like that, that means the concentration of whatever is inside the brackets. So the concentration of the HCl is going to be 0.020 moles of HCl in 80 milliliters. And 80 divided by 1,000 is 0.080 liters. You always want to have moles per liter. So that is going to give me a concentration of 0.250 molar. This will be the molar concentration of hydrochloric acid in my solution here. Now, usually when we do titrations in practice, the equivalence point is determined. So the equivalence point is the point at which the moles of H plus that we add are equal to the moles of OH minus that are present. So usually the equivalence point is determined in the lab with a color indicator. So there are many different types of chemicals that change color at different with different acidities. And there are, a number of different color indicators. One that you use really frequently in the chemistry lab is phenolphthalein, which is a word that I can never spell properly. I think it's something like this. Phenolphthalein. Phenolphthalein is colorless in acid, and then when it goes to base, it turns pink. So this is an example of a color indicator that is used to give you an equivalence point.